Optimizing databases and tables. In this nugget, I'm going to share with you several useful tips for conquering your exam objectives for optimizing tables, and of course these tips are equally applicable to your real-life world as database administrators. I'm going to give you tips for selecting the most appropriate data type for your table columns, and I'm also going to show you a really great function that I think is not all that well known about, frankly, in the MySQL DBA community. In the second part of this nugget, we're going to discuss a little bit on database normalization. This is a topic that any DBA worth his or her salt should be well familiar with. It does appear on the DBA2 exam objectives, therefore we will cover this subject to some degree of depth. Let's get started. Table optimization tips specific to MySQL Server. Well, frankly, half of this is specific to MySQL Server, but a lot of these tips in this particular nugget pertain to any relational database management system. One is a general principle that states normalize like crazy, denormalize sparingly. When you're building a relational database management system, you want to try to do everything you can on the front end in the database design phase to ensure that your database tables are as fully normalized or as close to the third normal form as possible at design time. And continually, as you're tweaking and tuning your tables, normalize them over time, but be careful about deconstructing or denormalizing. Denormalizing tends to, well, really defeat the purpose of normalization, which is to decrease or hopefully eliminate data redundancy. We'll talk more about normalization a little bit later in this nugget, though. Another important table optimization tip is to index wisely. We're going to look at our tables and our table columns and consider which of these columns is most frequently accessed by our users, by our queries, and this is going to guide us in selecting and creating our indexes. Pretty reasonable, right? A third important suggestion is to select the smallest data type that's feasible for each of our columns in our tables. And this speaks to a couple of different things. Now, it's true that disk space and disk storage has never been more inexpensive than it is today. As of this recording in October 2009, it seems that hard disk storage has never been cheaper. Nevertheless, I formally recommend, and I know the MySQL team would agree with me on this, that you should never use cheap disk storage as an excuse for being lazy in selecting a data type. Now, what you see on the right-hand side of this whiteboard is a table that I pulled from the MySQL reference manual. There's a really great article called Data Type Storage Requirements that breaks out, it discusses and then breaks out the specific storage required. In this case, this table is showing you the storage requirements by data type for the MyISAM storage engine. MyISAM, of course, is the default storage engine in MySQL Server. Down at the bottom, you'll notice my annotation. MyISAM storage engine has a hard-coded limit of a little over 65 kilobytes per row. Now, if you're coming from, say, Microsoft SQL Server, you've got a much smaller row size, a maximum row size of approximately 8K. Therefore, we have much wider rows in MyISAM for sure, but still we do have an upper limit. Therefore, we want to be careful when we're designing our tables in terms of the number of columns that we expect to store in that table, as well as the data types that we associate with each column, because each column, by definition, literally, is going to have a particular disk storage footprint. So you see in this table, if we use, for instance, the int or integer data type, this is, as you know, I'm sure, an extremely common data type for numeric data. Each row in that column, whether it's storing data or not, is going to occupy 4 bytes worth of space. That's 32 bits worth of data. All right? So as you're building out a table's worth of data, you've got column definitions, and each one of those you can kind of look at it as a continuum like this, where some of those data types are wider than others. And you always have to think, what is the maximum row size that I'm working with, depending upon the storage engine in use for that particular table. And again, you have to think also in terms of space efficiency. By using too large of a data type, you may not run into that maximum row size limitation, but you're still wasting disk space. Just like in the olden days of Windows, and by olden days we can just go back as little as 8-9 years, before NTFS file system became the standard, when you had FAT32 or even, heaven forbid, FAT16, you had the allocation unit or cluster going from 8K to 16K to even, heaven forbid, 32K. And when that was your minimum allocation unit on the hard disk, we were talking about a tremendous space wastage. So if you were storing, say, a 4K image or a 4K text file, you were in a 32K cluster allocation size on a partition. You were wasting 28K's worth of space just for that one file. Same kind of deal goes when you're using blocks in a MySQL table file. So we need to keep that in mind. I just can't hammer that home enough. We want to choose the smallest possible data type that's going to work. Now, of course, we don't want to be too parsimonious. We need to make sure we choose a data type that's large enough, but just not too large. Finally, we want to be judicious and use not null for a speed advantage. There is a slight speed advantage in queries where we specify not null, because when we do allow nulls for columns in a table, this simply slows down query processing. That's all there is to it. Using procedure analyze. Next up, I'd like to introduce you to a really neat function that I don't think many MySQL DBAs may know about. Certainly we need to be aware of this so you're not surprised when you take your DBA2 certification exam. What this function can do is give you some really neat suggestions for optimizing the data types in your columns to reduce your table size. So specifically, let me just read my definition. Procedure analyze is a function. It's actually a clause of the select statement, and this is just basically what I just told you. Useful for suggesting an optimal data type for each column to reduce your table size. I guess I literally did repeat that definition. The syntax is as follows. You run your select statement, and then appending at the end of your select statement, you just type procedure analyze. Now you notice the S here. We have the British English word analyze instead of the American English where we use the Z. Procedure analyze, and then if you're not passing in arguments, you would just use the empty parentheses. You don't forget about that because analyze is in fact a built-in function. You have two possible input parameters. If you don't include any input parameters, that's fine, but you've got two possibilities. The first one is called max elements, and if you put in an integer here, this caps the MySQL parser at a maximum number of distinct values that are enumerated. The default value is 256 from each column. And what this does basically is it looks for distinct values in each column, just like I said, in terms of seeing if it will suggest the enum data type for you. Now you should at this level be familiar with what each data type is and how MySQL data types work. The enum data type is pretty handy because the enum data type enables you to store more than one value in a single column. So you might create a column called department using the enum data type, and that enum data type might store, say, 5 or 6 different string values like accounting, administration, development, maintenance, and so on. And when you do data entry on that column, you would have to choose from that enum array, you see? So anyway, if you know you've got more than 256, that's kind of an absurd number. You can pass in a max elements of smaller than 256 or even higher. Now, max memory is a cap in terms of the memory allocation per column. The default is 8 megs. Again, this is just a way, if you've got a tremendous number of distinct values and a huge table, you can cap the amount of processing power that the analyze function devotes so you don't bring your server to its knees when you're running this thing. Now, I've found that the procedure analyze function works especially well when you run other metadata commands like show table status and describe. And in the upcoming demo, I'll show you exactly how we can use those three commands together to get some really interesting table optimization suggestions from our tables. What is database and specifically table normalization? The specific definition for normalization that I offer to you, my friends, is the structuring of our database tables in an optimal fashion toward the end of eliminating data redundancy and preventing waste and error. Now, the idea of a relational database management system is instead of maintaining just a single humongoid data table, now I'm not going to use the antiquated terms of tables, of domains and tuples and all that. We're just going to use the contemporary terms of rows and columns and so on. Instead of just putting everything into a single table, you know, the purpose of a relational database is that we granularly break out our data into multiple tables and we create joins or links between those tables, or among those tables, I should say, if we have three or more, on the basis of a matching key column. That's the whole thing. The matching column is what creates that umbilicus between those tables, or that relationship between those tables, and that gives us the magic ability to do cascading updates, cascading deletes, and most importantly, to do select statements and to retrieve data from all of those tables, and of course, just as importantly, to reduce or potentially, hopefully, eliminate redundancy, because we don't have to keep doing the same data input again and again and again and again and again. In other words, we might have an employees table over here, and we might have a customers table over here, and we might have an orders table over here. And of course, on the orders table, the same customer may show up 100 times, and the employee who checked those customers out, cashed them out of the store, may again show up hundreds of times in the orders table. We don't have to worry about the potential of data entry problems where the customer's name might be mistyped, the employee's ID number might be mistyped, all of that kind of stuff, because we've A, created only a single customer record in the customer table, only a single employee record in the employee table, and a single order record for each discrete order in the order table, and we're simply referencing each customer in the order table and referencing each employee from the order table to the employee table. We've got this really elegant solution. So those are some of the basic nutshell principles that make relational databases so elegant and wonderful. So this normalization process refers to making the table breakout process as discrete and granular as possible. One of my old mentors when I first got into IT a long time ago said, "Tim, you know how many columns a fully normalized database is going to have?" And she was speaking more in terms of theory than actual practice. And I said, "I don't know how many." And she said, 2. Ideally, an absolutely fully normalized database. Each table is going to have some kind of ID or key column that uniquely identifies every row in that table, and then there's going to be some data column that's associated with it. That's it. Now that's a fully normalized table where there's no other column in that table that doesn't depend entirely on the primary key for its existence. It's as simple as that. Now, is that going to work in a relational model? No, of course not, because in order to create a join, we would in this case have to create a third column that maps to the primary key in this first table, and vis-a-vis we would have to do the same over here and so on and so forth. But you get the general idea. Again, to summarize the benefits of this normalization process, we wind up creating joins and better joins, more efficient joins, and better query performance. We're eliminating redundant data, and we're avoiding the possibility of data entry errors. Redundancy means data inconsistency, doesn't it? If we have an inventory database and we're putting data in more than one table, more than one time, That means we're not being accurate with our inventory counts and we're not accurately reflecting the bottom line. And this could have legal implications, definitely accounting implications. If our company is under restriction of some of those federal guidelines like Sarbanes-Oxley or HIPAA and all, some of those sort of organizational, governmental, federal mandates, if we don't have a fully normalized database and we have some of this waste and error happening, we may fall out of compliance without knowing it. A third benefit is normalization, again, by virtue of the elimination of redundancy, is going to make for a more compact, faster, better performing database with smaller tables. Before we head into the demo, let's take a look at the normalization process in action. You don't need to know the deep dive details for your DBA2 exam. However, of all the explanations of the normalization process that I've seen, one of the most succinct and best explanations I've ever read is from an article at daleeman.com. And so I'm taking the text here and I'm going to expand upon it a little bit. According to Dale Eman, he says that first normal form, or 1NF as it's expressed in shorthand, states that your table exists with no duplicate columns, that your table is atomic. And that should be pretty easy as long as you've structured your table with discrete column names. Now you can get into trouble with first normal form if, for instance, you try to pack data into a single column with more than one value. Like the example I gave before with department. Unless you use a data type like enum, which is previously mentioned in this whiteboard, if you just were to define it as a standard string data type and a data entry operator were to put more than one value in a row, well, there you're starting to get into a little bit of problem there in terms of maintaining data consistency. But most of the time, if you do a fairly good job with just being discrete with your column names, first normal form isn't a problem. Second normal form means that your table is in first NF, and then you go about identifying and separating subsets of data that can be reused. So you're looking at data that you feel is repetitive and you can break out into a separate table. And I have a good example that comes to my mind. Let's say you have an employee table where you've got an ID column that's going to be your key column, your primary key column. You've got your traditional first name, last name, department, hire date. And let's say that as you're constructing the schema, the needs of your organization are such that you've got some badging information. So you decide, you've got a badge type and a badge ID and a badge expiration, blah, blah, blah. So you're just going along with the different columns. And as you're doing data entry, it occurs to you you're getting a lot of duplication. A lot of folks have a badge type of such and so, and a lot of folks have a badge expiration of a certain date. And then it starts to occur to you that this subset of columns is involving a lot of repetition. And wouldn't it be nice, and especially in the name of second normal form, why don't we create, in this case, a badges table, where we create a badge ID. You could potentially reuse this column, where you've got an ID column that serves as the key, and then define your other fields however you want. And then all you'd need to put back in the employee table is a foreign key constraint bound column called badge ID that's linked up to the primary key column in badges, you see? So that's the essence of second normal form. Most of your work, most of my work in the normalization process, I find is in second normal form, where you're looking for patterns, subsets of data that you're finding are reused, that are just repetitive, that you find you can break out into another table and then relate back to the source. And finally, to finish up, the third normal form, the blessed, hallowed third normal form, first you want to do everything you can to make sure that the table's already meeting the requirements of 1NF and 2NF. Then we remove all the data that's not directly related to the primary key. In other words, you go column by column and make sure that each and every column exists and only exists in terms of uniqueness because of its relation to the primary key value. In other words, that all of the data in the table is fully dependent on the primary key. In this example, let's say that in addition in our employee table, in addition to ID, first name, last name, department, hire date, we also had a monthly salary column. And then let's say we had a calculated column for annual salary. And I'll just put an asterisk there to let us know that this is calculated. The test for third normal form is you ask yourself, column by column, is the first name column dependent upon ID? In other words, let's say we have a Tim. This Tim Warner in the IT department who had a hire date of such and so is the only way this guy is fully unique in the employee column, in the employee table, because he's ID number 1. I mean, possibly there could be another Tim Warner in the IT department with my hire date, with my monthly salary. I mean, it's unlikely, but it's possible, right? But it's impossible because of the primary key constraint that there's another employee ID 1. So third normal form ensures that every column is dependent upon the primary key for its uniqueness. And if you have a column that's not dependent upon the primary key, you should get rid of that column. And in this case, the reason why I added this last column is because this calculated column does not depend upon the primary key. The monthly salary does, but the annual salary column is a computation of monthly salary times 12, isn't it? So since this column here is derived and depends upon another column, not the ID, we can get rid of it. And if we did need to see the annual salary, we can simply run a select statement or create a view function, whatever we wanted to do to get that information. Believe me, this kind of monkey business does not belong in a base table. Time for our demo. In our demonstration, we're going to work with table optimizations and normalization. Let's get rocking. Let's get this party started. We're on LinNugget 1 and pop open a command shell. You see I've logged into MySQL server as root. I'm using the world sample database and I'm showing a run of our tables. We're going to get right into this by using the procedure analyze command. Although first I found table optimization and normalization. Describe can come in awfully handy because, as you'll see, we'll just run this on, actually let's do it on city first. Describe gives us a really nice succinct list of the fields, also called columns, their current data type, their nullability, any index keys that are set, chiefly primary key, default values, and then extras. So this is the current setup of the city table. Pretty straightforward table. Now what we're going to do is simply run select splat from city, procedure analyze with that S, without any input parameters. Definitely run the backslash uppercase G escape character to get a vertical row display on this. And then you'll get a row for each column in the table. So what we'll do is take this row by row. First row is the ID field, and just to jump right down to the bottom, the last one is the money here, optimal field type. What MySQL is recommending here is the small int 4 data type, unsigned, not null, interestingly. So here we might really want to look into this a little bit and consider actually changing the data type for the ID field. Second column we'll notice is name and it's char 35. Let's take a look and see what MySQL is suggesting. They're suggesting varchar 33, not null. Remember, not null is going to give us speedier queries, so chances are, dollars to donuts, the analyze function is going to recommend not null fairly often. Of course, this brings up another somewhat related discussion of whether to go for char or varchar when you have approximately the same amount of data for a particular column. We could argue that all day probably. Country code, it's pretty straightforward there. If you have familiarity with this table, we've used it a lot in this Nugget series. It's just 3 letters. So char 3 makes sense here. Let's see what MySQL says. They're recommending enum, I'm not sure I agree with them on this. Now, that brings up a good point, actually. Please don't just consider MySQL Procedure Analyze to be the be-all, end-all in terms of their suggestions are always golden. Here, they're taking every unique value that it finds up to the default of 256 and suggesting a field type of enum. This is a lot to take in. Not sure I recommend that at all, quite frankly. Row 4, it's suggesting varchar 20 not null. Let's go back up to the table instead of char 20. Guess that's a judgment call. Population, the original data type is int 11, and they're recommending medium int unsigned. There you have it. Now, also, without just continuing on too quickly here, besides the optimum field type, I want you to see that we do have some numbers to back up the row data beyond that. This is really interesting. We have min values and max values, min lengths and max lengths. So besides just MySQL giving you an optimum field type and saying, take my word for it, you have some mins and max to kind of put in your theoretical pipe and smoke, including an average and standard value. So if you're an analytical kind of person here, that's pretty handy to have. Alrighty then, so there's the describe command, the procedure analyze command, and then another tool that you should be familiar with if you don't already know is show table status. Now to use this one, you actually have to use like and then put the table name in string delimiters. Let me invoke that with the / uppercase G. Show table status is cool because it gives you some more metadata that can be helpful when you're doing table optimizations like this. Gives you, in a nice nutshell format, your storage engine, your row format, fixed or variable, the number of data rows, the average row length, very helpful, data length, very important, maximum data length. There you have it. Very quick introduction to table optimization tools in MySQL 5. Optimizing databases and tables review. In this nugget, we looked at a few different ways that you can improve the performance and storage of your tables in MySQL Server. We looked at optimizing data types, both from a database design standpoint, as well as using some built-in tools, including the procedure analyze function. I hope that you're a big fan of it. I know that I am. Second part of this nugget, we looked at the time-tested and true tool of database normalization. As far as I'm concerned, you can never stop studying enough about database normalization, for sure. I hope that this has been informative for you, and I'd like to thank you for viewing.